And here we go.
Let me read the question now. Diagram 3 shows a triangle BOA. The straight line OX and BY intersect at point P. Okay, so this is the straight line OX and this is the straight line BY intersecting at the point P over here. Okay, continue to read the question. It is given that vector OA is equals to 4A, vector AX is equals to B, 3 times with vector BX is equals to 2 times of the vector BA, and vector OY is equals to 4 over 3. Oh, it's actually a typo, guys. Okay, it's not 4 over 3, it should be 3 over 4. Okay, so please take a note, it's actually a printing mistake. It should be 3 over 4 OA, because over here in the Malay version it's 3 over 4, but then in the English version here it is 4 over 3, so you follow the 3 over 4 version. Okay, the 4 over 3 is the wrong one. Okay, so let me read for the question part A. Express in terms of component A and component B for the vector OX and vector BY. Okay, continue to read for the question part B. If vector OP is equals to lambda times with vector OX such that lambda is a constant, find the ratio of BP is to PY. Okay, so this is the oral question. So without further ado, let us begin our discussion for the question 6A part 1. Okay, so from here, question A part 1, we are required to find the vector OX. Okay, so vector OX, so this is actually the vector OX over here. So to find a vector OX, so literally we can use a vector OA is given by the question. Okay, vector OA, and then you plus with the vector AX. Okay, very straightforward. From there you can straight away get the vector OX. Okay, so from here vector OX, okay, is equals to vector OA plus with vector AX. Okay, so from here vector OX will be equals to 4A plus with B. Okay, so this is your answer for the question 6A part 1. So let me underline the solution. So very short question. Okay, continue to the A part 2 where we need to find for the vector BY. Okay, for vector BY, the option is quite big. Okay, you can either use a vector BO plus with OP or vector BA plus with AY. Okay, the options are quite big. Okay, there is no specific way. Okay, so from here, before proceeding to find for the vector BY, so in this case what I am going to do is I'm going to proceed with the BY will be equals to vector BA plus with vector AY. Okay, so this is my methodology and how I'm going to solve this vector question, guys. Okay, so from here in the question over here they already gave us that vector OY is equals to 3 over 4 times with the vector OA, and they already gave us that vector OA is equals to 4A. Okay, so from here we can use the information to find the vector OY. So our very first step is by finding the vector OY. Okay, so from here vector OY is equals to 3 over 4 times with the vector OA. So from here vector OY is equals to 3 over 4 times with vector OA. OA in this case is 4A. So you just substitute inside times with 4A. Okay, you calculate this. You should get your vector OY is equals to 3A. Okay, so this is literally one of the step. Okay, so from here vector OY is actually 3 over 4 of vector OA. So that means that this component here will be 1 over 4. If this section is 3 over 4, over here should be 1 over 4. Okay, so I hope you guys are clear about this. Okay, so from here ya, okay, vector ya will be equals to 1 over 4 times with the vector oa. Okay, how I get ya? Ya is actually towards from y to a, that's why I mentioned it as vector ya. So ya is equals to 1 over 4 times with the vector oa. Okay, so from here vector ya is equals to 1 over 4. Okay, vector oa in this case is 4a. Okay, you times them together, you should get your vector ya is equals to a. Okay, so let me underline this as well. Okay, this will probably useful towards our final working. Okay, but for now we hold it first. Okay, so now let us focus on the this information, set of information where 3 times with vector bx is equal to 2 times with the vector ba. Okay, so from here let us write it down. So from here 3 times with vector bx is equals to 2 times with the vector ba. Okay, so from here there are relation between bx and ba. So from here let us change it in a proper way. So from here the 3, we're going to divide the whole equation by 3. So from here vector bx, from here it will be equals to 2 over 3 times with vector ba. Okay, so let me scroll up. So for me to explain in the image, okay, in the diagram over here. So from here bx, okay, so this is actually your section bx. So vector bx is equals to 2 over 3 times with the vector, the whole vector ba. So which means that, so this b x is actually 2 over 3 and this xa is actually 1 over 3. Okay, but remember in the question they gave us ax is equals to b. Okay, so ax they already gave us as vector b. Okay, so if ax is equals to vector b, xa will be the opposite direction. Opposite direction means xa, vector xa will be equals to negative b. Okay, opposite direction, so opposite direction will be negative symbol. Okay, so from here, so from this information we get to know that vector xa is actually equals to 1 over 3 times with the vector ba. Okay, so from here xa, vector xa is negative b. Okay, negative b is equals to 1 over 3 times with vector ba. Okay, so from here you calculate this, you should get your vector ba is equals to negative 3b. Okay, for this chapter you just need to be careful on the direction of the vector, guys. Okay, the magnitude and the direction. Okay, so from here we have already done. Okay, since we are required to find the by, okay, now we already have the vector ba and then we already have the vector ay. You might be wondering, how come we get the vector ay? Remember, guys, vector ay is the opposite direction of the vector ya, or vice versa. Okay, guys, so in this case ya, we can literally change it the direction to become vector ay. Okay, so from here towards our final step we're going to find the vector by. So from here vector by is equals to vector ba plus with vector ay. Okay, so from here vector by is equals to, okay, vector ba we already got it, very straightforward, is negative 3b. Okay, however vector ay you need to be careful. Okay, here you have vector ya which is a. Vector ay is the opposite direction of ya, so in this case it will be negative a. Okay, so from here vector by will be equals to negative a minus 3b. Okay, so this is your answer for the question A part 2. Okay, let me underline this. So I hope you guys are clear about this. Okay, so you just need to be clear on how you're going to solve the vector question, and then you need to gather the information, and you just need to be careful on their direction. Okay, sometimes students make mistakes on the direction. Instead of negative, they put it positive. Instead of positive, they might put it as negative symbol. So just be careful on the vector. As you do more practice, I'm sure you can able to master this. Okay, so no worries. So from here, okay, we are done with the question A discussion. Okay, so let us move on to the question B. Okay, question B, so it's actually involving the collinear concept. As you can see here, vector OP is equals to lambda OX. Okay, vector OP, okay, is lambda OX. What does this mean, guys? This statement means that OPX 3 points are collinear. Okay, where lambda is a constant. Okay, they ask us to find BP is to PY. Okay, BPY, as you can see here, these two straight line, I mean BPY also consider a collinear. Okay, there are two collinear lines intersecting at the point P. Okay, so when two straight line intersecting, technically you must have an idea that you must be involving with two variables, and you need to come up with two sets of equations. Okay, so let us solve this one by one. Okay, so let me begin our discussion for the part B. Okay, so from here in the question, we already know that OP, okay, is equals to lambda OX. This is one of the direct statement by the question. Okay, another statement that we can actually form is this. BP, okay, you can set it as a coefficient with a BY. Okay, there are something related to BY, right? Because as you can see here, BPY, 3 points are collinear to each other. They are aligned at the same line. Okay, so you can use any other variable. So in this case, I'm going to use as letter K over here. Okay, you can use any other letters. Okay, so let me address this as letter K. So from here, BP is also equals to K times with vector BY. Okay, you have two important equations. These two important equations indicates that the lines are collinear. Okay, so from here, let us begin our relationship between these two statements. Okay, so from here, how are we going to continue? So let us start with this. Okay, so from here, by begin with the relationship of the BP over here, vector BP. So from here, technically, how can you find the vector BP? Okay, so vector BP you can find, okay, by addition of the two vectors by vector BO plus with vector OP. Okay, so from here, let us continue. So from here, BP is equals to vector BO plus with vector OP. Okay, and as you know, BP is also equals to K times with vector BY. So this expression we can substitute over here. K times with vector BY is equals to, okay, vector BO. In this case, you can further express it. Okay, this vector BO, we can further express it by addition of another two vectors, which is vector BA plus with AO. Okay, so vector BA plus with AO, vector BA plus with vector AO. Okay, I know it's a bit confusing, but please stay with me, guys. Okay, and then plus with, okay, this lambda OP, so we're going to substitute over here. Okay, plus with lambda OX. Lambda OX is actually very straightforward. Okay, lambda OX, how to find lambda OX is OA plus with AX, okay, which we already find in the question A part 1, which in this case is 4A plus with B. Okay, so we just substitute this 4A plus B over here. So lambda times with 4A plus with b, okay, close bracket. Okay, so from here let us solve them one by one. Okay, so from here k times with vector by, okay, is equals to, so from here vector ba, so in this case, okay, vector ba we have already get is negative 3b, okay, in our early discussion. So negative 3b, okay, and then for vector AO, okay, OA is for A. AO is the opposite of vector OA. So in this case, AO will be negative 4A or minus 4A. Okay, plus with lambda times with 4A plus with B, close bracket. Okay, so from here let us times in the constants respectively. Okay, the over the left hand side, okay, we already have the vector by. Okay, vector by we have already find in the question A part 2. Okay, we can substitute here, which is negative A minus 3b. Okay, we should have substitute in the second working. Just give me a minute. Okay, so from here we're going to expand the constants respectively. So from here negative ka minus 3k component b is equals to, okay, negative 3 b minus 4a plus with 4 lambda a plus with lambda b. Okay, okay, so from here we can group the component A and component B together. So from here negative ka minus 3 kb is equals to negative 4 plus with 4 lambda component A, okay, and then plus with negative 3 plus with lambda component B. Okay, you group them together. Okay, instead of writing all the in an expression, okay, you just factor them out and group them together, guys. Okay, so this is the expression so far. Okay, so from here we can easily compare the component A and component B respectively. So from here negative 4 plus with 4 lambda is equals to negative k. So this will be your first equation. Okay, so from here negative 3 plus with lambda is equals to negative 3k. So this will be your second equation. Okay, so from here since you have two variables, you need to form one equation, and then from here you need to eliminate from two variable into one single variable. Okay, simple concept, guys. Two variables, two equations. Okay, from here onwards it will be very straightforward. It will be a simultaneous equation. Okay, so from here by using the equation 2, we're going to form equation of lambda in terms of k. So from here lambda is equals to 3 minus with 3k. So this will be your third equation. So you're going to substitute equation 3 into equation 2. Okay, so from here what you're going to do is so sorry guys, it's not equation 2, it's actually equation 1. Okay, so sorry. Okay, so we're going to substitute equation 3 into 1 over here. So from here, negative 4 plus with 4 times with 3 minus 3k is equals to negative k. So from here, negative 4 plus with 12 minus with 4 times with negative 3 will be 12k, so equals to negative k. So from here, negative 4 plus with 12 you get is 8. Okay, this 12 from the left hand side, move it over to the right hand side, so you'll get 11k. So 8 is equal to 11k. So from here, technically your k will be equals to 8 over 11, or you want to write like this also can. Okay, you write and then you swap the sides. Okay, so from here 11k is equals to 8, so from here k will be equals to 8 over 11. Okay, so once you get the k value, so what you can do now is very straightforward. So bp is equals to, instead of writing k times it by, you can write 8 over 11 times it vector by. So bp is equals to 8 over 11 times it vector by. So from here bp and py, so by is actually 11. Okay, bp is actually 8, so py is representing as 3. Remember guys, summation of a ratio, so 8 plus 3 you get is 11. So from here we can conclude that ratio of bp is to py will be equals to 8 is to 3. So this will be your final answer. I know it's a bit tricky. Okay, so technically what we are doing here, okay, at first we have two collinear equations, okay, and then from there we solve them one by one. Okay, by begin with the vector bp, okay, and then from the vector bp we related to vector by. Okay, we related to vector by, and from there we come up with the calculations, and that's how we managed to get the final equations. Okay, so let me scroll the question up. Okay, we have come to the end of our discussion for the SPM 2021 paper 2 question 6. If you like this video, make sure that you give a thumbs up, and if you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.